Okay, so this is part 2 of topic 4. So here, let me go back up to what it was asking us to do the FOIL method. So we're going to continue the FOIL method on number 20. So remember, the FOIL method means we take the first term and multiply it in, so this 3x, and multiply it in. And then we take the second term, so that 3, and multiply it in. So after we do all this multiplication, we will have 4 terms. So 3x times 3x is 9x squared. 3x times 2 is 6x. So I was following the red arrows. Now I'm following the blue ones. So 3 times 3x, again 6x, or sorry, 9x. Okay. And then 3 times 2 is 6. Okay. Once we FOIL, we have to combine like terms. Those are going to be always our middle terms. So we have 9x squared plus 15x plus 6. And that is our answer. Okay, go ahead and work on number 21 for a few seconds. Remember, we're FOILing, we're multiplying the first term and then multiplying the second term. Just make sure when you multiply that second term that you are including that -1. Okay, so the first thing you multiplied was that 8b by 5b, which is 40b squared. And then 8b times 5, which is 40b. Then on the blue arrows, we're multiplying that -1. So -1 times 5b is -5b. -1 times 5 is -5. Combining our like terms, we get 40b squared plus 35b minus 5. Any questions on the FOIL method? Okay, the next concept here is GCF. So GCF stands for the greatest common factor. And this greatest common factor is the largest factor that all the numbers share. So we are going to factor out the GCF from each expression. So looking at number 22, we have how many terms here? Good, we have 2 terms. So when we are looking at these 2 terms, we're first going to find the GCF of just the numbers. So first we're finding the GCF of 16 and 4. What's the largest number that can divide into both? 4. So far our GCF is equal to 4. Okay, now we're looking at the variables. So we have x to the 4th and x to the 3rd. What is the largest amount of x's we could take out of both?
3.
Yep, x cubed, x to the 3rd. So when we're looking at our variables, we're always looking at the one that has the lowest amount. So the one that has the smallest exponent is usually what we can take out of both. Okay. So this is just the GCF. Now we need to factor out that GCF. So we're going to take that 4x cubed, and then we're going to write parentheses after it. So what we're doing with that 4x cubed, that GCF, is we're going to divide each of the terms by the GCF. So starting with the first term, 16x to the 4th, we are dividing that 16 by 4, and we get 16 divided by 4, 4. And then x to the 4th divided by x to the 3rd means we do what to the exponents? Subtract. So we're going to be left with how many x's? 1. So 4x. And then plus, what is 4x cubed divided by 4x cubed?
1x.
Just 1. Okay? Because if we do x cubed divided by x cubed, that's the same as saying x to the 3 minus 3, which is 0. And then anything to the 0 power is 1. Okay, so that means our answer here is this part right here. And I'm going to go ahead and erase that parenthesis so I can put it a little closer. So our answer when it's asking you to factor out the GCF is going to be the GCF next to a parenthesis, whatever you're factoring out. If it's just asking you to solve for the GCF, then you would just write the first part. But in these questions, it's asking us to factor out the GCF. Any questions on 22? Yes?
So for like the power numbers, like 4 and 3, it's always going to be, like the GCF is always going to be the lower number?
Correct, correct. And if we have more than one variable, then it's going to be the lowest number for x, and then the lowest number for y, and so on and so forth. I think we'll see some of that here. Okay, 23, how many terms do we have?
1.
We have 2 terms. Remember, the terms are what's separated by a plus or a minus. So from these 2 terms, the first thing we're going to do is the numbers. So what is the largest number that can divide into 9 and 36? 9. So GCF is equal to 9. Are we able to take a GCF from the variables? No. So then our GCF is just 9. So we're going to write 9, and then we're going to write our parentheses and start dividing that 9 into 9x plus 36. So 9x divided by 9 is just x. And then 36 divided by 9? 4. So that means our answer is that 9 times x plus 4. So we factored out our GCF, which was 9. Okay. Number 24, how many terms? 3. We have 3 terms now, so we're going to be looking at 3 numbers and 3 variables. So factoring out the numbers first, so we have 14, 21, and 21. What's the largest number that we can take from all 3? 7. So our GCF is going to start with 7. And what is the largest amount of x's we can take out from all?
2.
1 or 2? 1, because of this one right here. There's only 1 here, meaning we can only take out 1 from each of them. Always the lowest one. So that means our GCF is 7x, and we're going to start dividing everything by that 7x to factor it out. So 14x divided by 7x is 2. 21x squared divided by 7x? 3x. And 21x cubed divided by 7x? 3x squared. And that's our answer. So all we're doing is factoring out what every term has in common. Okay? Go ahead and try 25. So remember, first thing, what's the largest of the numbers? And then largest of the variables. Okay, from the numbers, what's the largest number that you found divides into both? 7. So GCF is equal to 7. How many x's?
6.
To the 6. X to the 6. Okay, so we're going to take 7x to the 6 and divide it into our problem. So 63x to the 12th divided by 7x to the 6 is... Good, 9x to the 6, because 63 divided by 7 is 9. X to the 12th divided by x to the 6. We subtract those exponents, and that's how we got x to the 6. What about 35x to the 6 divided by 7x to the 6? Good, -5, because I'm bringing down that negative that was right here. Okay, and that's our answer. Again, just bringing that parenthesis closer. There we go. Okay. Okay, looking at 26, how many terms do we have? And is our GCF going to include variables? No, so just the number. So what is the largest number that can go into all three of those? Good, 5. So GCF is just equal to 5. We're going to divide that 5 in. So 20 divided by 5? -35x squared divided by 5?
7x squared.
Good, -7x squared. And lastly, -20x cubed divided by 5. Good, -4x cubed. Notice that all the variables stayed the same. The only thing we were just dividing is the numbers. That was just because our GCF only consisted of a 5. Okay. Same with 27. We're only going to be taking out a number. What is that GCF? 4. Good. So it's the number that can go into 12, 4, and 12, and we said this is 4. So if we divide everything by 4, what's going to be left inside our parentheses?
3x squared plus x minus 3.
Perfect. And that was us taking every single term here and dividing it by 4. Second term divided by 4. Last term divided by 4. Okay, any questions on GCF? Okay. Next concept is simplifying expressions. So here we're going to have multiple expressions, and they're going to be separated by either a plus sign or a minus sign. So looking at example 28, our first step is to get rid of all of these parentheses. And we can only do that once we deal with this negative here, this minus here. Okay? This negative is telling us we're going to have to do what to the parentheses after it? Distribute. And what are we distributing? A -1. Okay? So we're going to distribute a -1 to everything inside those second parentheses. Do we need the parentheses on the first expression? No, so we can just drop those. So I'm going to go ahead and drop those parentheses. So I have -7n squared plus 8n minus 4. And then I'm going to start distributing that -1. So -1 times -11n is a positive 11n. -1 times positive 2 is a -2. And -1 times a -14n squared is a positive 14n squared. So what did distributing that negative do to all of these signs? Good, it just changed them to the opposite. Okay, so we had a -11n, now we have a positive. Positive 2, now we have a negative. So on and so forth. Okay. Once we distributed that, the parentheses went away. So now we have a problem without any parentheses. And then what is going to be our last step? Combine like terms. Good. So first, let's look at n squares. So we have another n square at the end.
So 7n squared?
correct? And then we have our n's, and then we have our constants. So combining our n squares, we have 7n squared. Combining our n's, we have what? 19n. And then what about our constants? Negative 6. Good. That's our answer. So the only ones that are going to really require any work is if you see two expressions that are being subtracted. What if we saw two expressions being added? Would we need the parentheses? No. And we're going to see an example like that coming up. Okay, so looking at 29, what is our first step here? Good. We distribute this negative, and then we know when we distribute that, it changes all the signs. So this is positive now. This one is negative, and this one is positive. Okay, now that we changed all the signs, do we need any of the parentheses anymore? No. So we have 14p to the fourth plus 11p squared minus 9p to the fifth. We're ignoring this because we already distributed it. And then this is now a positive 14, a negative 5p to the fifth, and a positive 11p squared. So all I did was change the signs after the parentheses right here, and then dropped all parentheses from the problem. Okay. Now I'm combining like terms, so I have a p to the fourth, which looks like it's by itself, 2p squareds, 2p to the fifths, and then a constant. So even though this 14p to the fourth comes first, which one do you think we should write first if we're putting it in proper form? Good, that p to the fifth, because when we are writing expressions, we always want the highest exponent all the way to the lowest exponent. So we're going to start with that p to the fifth. If we combine them, what do we get?
Negative 14p to the fifth.
Good, negative 14p to the fifth. And I just realized I should have made this one a different color. Okay, then we're just going to bring down that plus 14p to the fourth because it's by itself. And then what's the next part that we're simplifying? Good, so we have 211p squared, so that's 22p squared. And then we bring down that plus 14. So this is our answer. So if on a test you write the exponents out of order, I will be taking off points. Okay, so we have to make sure that our exponents are always decreasing in the problem. Okay, go ahead and take a few seconds to work on 30. So it's another one with those two expressions being subtracted. Okay, I'm going to go ahead and start writing it out. We do not need the parentheses on the first expression, so I'm just going to bring that first expression down. On the second expression, all of these signs change. Okay. Now I have a expression without any parentheses. Combining like terms. First, I just highlight everything that's going to be similar. And then if I was writing out my answer, what is going to have to come first?
3k squared.
That 3k squared, because the squared is the highest exponent. And then it's going to go, which one?
18k.
18k. And then finally, yep, negative 13. Always do the highest exponent, and then we decrease after. Okay. How many expressions do we have in 31? We have 3, because remember, an expression is something separated by that plus sign. So we have the first parentheses, the second parentheses, and the third parentheses. Since these are all being added, do we need any of these parentheses? No, so we can go ahead and rewrite our problem without any parentheses. So for this part right here, since I have plus a negative, what can I write? Just a minus, right? I don't need to write that plus a negative. I can just write minus 2UB. Same with that last one. Okay, so all I did was drop those parentheses. Now I can start combining like terms. So I'm going to first just go through and highlight. Okay. So in this case, we have two variables that have the highest exponent. We have that v squared and that u squared. In this case, it doesn't matter if you put u first or v first, as long as the squares are first. So if we start off with v squared, we have negative 9 plus 1 minus 1. So what's going to be out in the front?
9 squared,
Negative 9v squared. Okay. Then we have to look at the u squares. There's only one u squared, so I'm going to bring it down. That's that negative 2u squared. Okay. And then what would come next? Would it the uv variable come next or the u? uv. So we have plus 2uv and then that negative 8u. This is our answer. Okay, yeah. Okay, number 32, notice we have two subtraction signs. That means you're going to have to distribute twice. Okay, we're changing the signs twice for the two expressions at the end. Okay. Again, all that tells us is we're just changing the signs. So we now a positive, positive, positive. This one is negative and negative. So I rewrite this as 4x squared plus 7x cubed y squared plus 6x squared plus 7x cubed y squared plus 4x minus 10x minus 9x squared. Okay. That was me rewriting without the parentheses, and then those last two expressions had the signs changed. Then I'm going to work on combining like terms. So my x squareds, then my x cubed, y cubed, oops, and then my x's. Okay. What variable is going to come first? Good, x cubed, y squared. Why? Good, there's multiple variables, and that the x has the highest exponent of that x squared. So 7 plus 7, so that's 14x cubed y squared. And then we are going to do our x cubed. So we have 4 plus 6 minus 9, which is x squared, so 1x squared. We don't need to write the 1. And then lastly, 4x minus 10x, negative 6x. Okay. On number 33, do we need those parentheses?
No.
Why?
It's added.
Good, all of them are being added, so we don't need any of the parentheses, so we can go ahead and drop them right away. So I'm just gonna rewrite this without the parentheses. Again, I'm writing out every single step. You could just cross out the parentheses if you have this printed in front of you. Okay. Then I'm gonna start highlighting my like terms. So I have a u cubed v to the 4th. Then I have just u's. Did I write that one correctly? Yeah. And then these ones are separate. Okay. Which variables am I writing first? Okay, so for these ones, since we're dealing with all the u's and the v's, it doesn't matter if we choose to put what I highlighted in blue first, because it does have v to the 4th, or if I choose to do this yellow one first, because it also has u to the 4th. So it doesn't matter which one comes first, as long as the other one comes next. So I'm just going to write negative 8u to the 4th v squared. And then combining all the ones I have highlighted in blue, I have negative 5 plus negative 5, which is negative 10. Negative 10 plus 8. Negative 2, u3, yeah. Okay, and then I'm just going to bring down what I have highlighted in green because it's by itself. So that 8u squared v squared. And then lastly, these u's, I have 9u minus 8u, which is just u. That's my answer. Okay. Sorry.
Is there a GCF?
Okay, so there is a GCF on 33, but it was just asking us to simplify the expression, so we're not going to take out that GCF. When we work on separate problems, where I tell you to just simplify as a whole, we'll take out the GCF, but this concept is just combining like terms. Yes.
So that's 10u, right? 10u to,
Got it? Okay, but that's great to acknowledge. Yes, we could take out a GCF from this problem. Okay, and remember, this is all being recorded, so you can always go back and look at it. For 34, do we need the parentheses? No, so I'm just going to cross out the parentheses here instead of rewriting it. So I'm saying if you have the paper in front of you. Okay, now I'm just going to go and highlight common terms. So I have xy cubed. Any more? Yep, xy cubed. Xy cubed. And then x to the 4th, y cubed. And then this y to the 4th by itself. And this 8x to the 4th, y to the 4th by itself. So which one would I write first? Good. X to the 4th, y to the 4th, because they both contain the highest variable for the x's and the y's. So negative 8x to the 4th, y to the 4th. What would be next? Good, so we could choose to either put that x to the fourth y cubed or that y to the fourth, because they both have those high terms. I'm going to go ahead and just combine my negative 9x to the fourth y cubed plus my positive 3x to the fourth y cubed, and I get negative 6x to the fourth y cubed. Bring down that plus 7y to the fourth because it's by itself. And then, let's see, I got those. Okay, so then I have everything highlighted in pink. So negative 9 plus 3 plus 2 is
4xy cubed.
negative 4xy cubed. Okay. Then lastly, number 35. You're only going to have to change the sign on how many expressions?
One.
One expression, just that last one right here, and they're both going to be negative. Okay. So I'm just going to go ahead and rewrite it while you're combining the like terms. Again, this concept is just going over combining like terms. You're never going to have problems like this that have all these mixed variables in it. Okay, I went ahead and highlighted all my common terms. Which variables are going to come first?
The x4, y4.
X4, Y4. So we have negative 7 plus 4, which is negative 3, plus negative 6, which is
Negative 9x4, y4.
negative 9x4, y4. And then I'm going to go ahead and bring down that negative 10x4, y cubed plus negative x4, y cubed, which is going to give me negative 11x to the fourth y cubed. And then lastly, these y cubes, I have 1 y cubed and 6y cubed, which gives me 7y cubed.